All right. Good morning, year sevens. How are you today? Let us know in the chat. I'm going to ask Yaz to jump in, and we're going to have a quick chat before we start while we wait for some more people to come in. Good morning, Yaz.
Good morning. How are you?
I am great this morning. This is the last ever Mathspace Academy that we're going to be running this week, so it's a little bit sad.
It is a bit sad.
Yeah, everyone's going back to school, as we can see in the numbers. There's probably, there's a handful of people. There's maybe 4 or 5 people in here with us today.
Yeah.
Just wanted to say before we started, thank you so much for helping us out for the last 6 or 7 weeks, or it's actually 8 now, Yaz. Thank you.
It's been my pleasure. I really liked it. It's fun to go back to this type of stuff. So, and I hope all the kids liked it too as well. It was fun.
Absolutely. Yeah, no. Thank you so much to all the people who have been joining every single week. There's definitely a couple of names that I recognize for now. So I hope you're finding value out of what we've been doing. And again, there'll be one last survey at the end of this session. So please give us your feedback. Tell us what you thought about the whole last 8 weeks. So anyway, my question for you today, Yaz, is if there was one thing that you could learn or one skill that you could gain, what would you learn?
Oh, this is a tough one because there's so many things that I don't know. I think that I wish that I could program really well. I feel like that would be super useful.
Really?
I know you can learn to program. Pardon?
It's such a rare, I would never have thought of that.
Really?
Yeah.
I feel like it's so powerful. Like if you can program really well, and I know you can learn, but I don't know if I could just instantly master it, that would be amazing.
Okay, cool. What about people on the call, on the webinar? Tell us, what would you want to learn if you could, like instantly? What skill would you want?
Yeah, you could play an instrument, anything.
Yeah, I'm just thinking about mine.
Yeah, what would yours be?
One of mine, I have a number. One of mine is that I would love to know how to dance. I'm a terrible dancer. I'm so ashamed of it. So at weddings or at parties, like I'm just not in the crowd. You know what I mean? So I think it'd just be so much more fun to be able to get up there and dance. And I also I have a daughter now, and I just wish. Well, I just when she wants to, that I can dance with her and just have fun with her.
Yeah, I'm also a terrible dancer. Everybody tells me that I have 4 signature moves, and it's like with my hands in the air, and they're like, "Oh, it's the Yasmin move." And I'm like,
"Oh." You got a move named after you. Well, I mean, as long as you have no shame, I think not being able to dance doesn't matter at all.
Yeah, right. It's the confidence that comes with it. Do you dance with your daughter when you're watching like Disney movies and stuff?
Yeah, absolutely.
You dance, yeah.
Yeah. I try and get into it, but I'm very wary that she'll end up copying me, which is bad.
That's so funny. Do you have a favorite Disney movie, actually?
Oh, my favorite Disney movie. I don't really have a favorite as such. There's probably like a standout few. I think one of the ones that I've probably watched the most is Lion King. Just as a kid. Yeah, as a kid, just had a tape of it and just watched it over and over and over again. Yeah. But I don't know if year sevens know what tapes are.
The videotapes? Is that what you do? Yeah. We used to watch those and rewind it, go to the end. Aurelia knows what a tape is.
So in the chat, tell us, what was your favorite animation or your favorite Disney film?
Yeah.
What about yours, Yaz?
Pardon?
What about yours?
Oh, you know what? I didn't think. I didn't actually watch a lot of. I think my favorite now is probably something like Mulan. Mulan is a really good movie.
Really?
Yeah, I really like Mulan. But I think that Frozen does have a couple of bangers in it as well. So it's always fun to sing along. So
yeah. the best song is out of Mulan is like the Make a Man Out of You. Have you heard that one?
Yes, yeah. I
Such a
can't remember
good
how it
song.
goes. It's so good.
Year sevens, if you ever need a pump up song and you're like trying to study or trying to work out, listen to that song. It's amazing. Yeah, out of we probably should wrap up this chat soon, but I just want to shout out there. I've started watching kids animations with my daughter, and what I find actually really enjoyable, really smart, really funny is Bluey. Have you ever seen Bluey?
Bluey? No, what's Bluey?
Bluey is an Australian animation, actually, basically for kids about dogs, and it is amazing.
Oh my gosh, I'm gonna, oh, Aurelia watches it every night. She knows what you're on about.
Yeah, that's so good.
Um,
Beauty
I
and the
have
Beast
to
was
look into it.
someone else's. Yeah, I've never actually seen Beauty and the Beast, and
Yeah.
I haven't seen Frozen 2 either. Okay, let's make a start. We should stop chatting about cartoons. So we've got 3 of us in here today, so it's a pretty small group. I guess please feel free to chat and type because there's not many people in here with us, so speak up. Love you to do that. All right, so let's get into this. Thanks for chatting, Yaz.
Thank you. Bye.
All right, see ya. All right, today, ladies and gentlemen, we are going to be doing algebra. Now, show of hands up if you've already started this or done some of this in your class already. Anyone? If you go to the chat, there's a little section that says you can put up your hand. All right, someone's 1 out of 3 started already. Now we're going to be 2. We're going to be doing the basics, and if you're okay with the basics and need to move on, please feel free to let me know, and we can kind of go off topic and do other stuff. But this is just what I've got planned for today. So. Oh, we've already done this. We're going to be playing a little mini game, which isn't really a game as such. It's like a little on-call puzzle or thing that I'm going to get us to do. And then we're going to. I obviously haven't finished this slide because we're not doing operations with integers and we're not doing Kahoot. But then I'll go into some teaching, and then we'll actually play GimKit because that was probably the most shouted out one last week. So I thought we would give that another go. All right, so I've got a little game or puzzle for us today. And since there's only 3 of you, you're going to need to be on the keyboard to type here. This is the game. I've got a machine. And in this machine, I can put in some numbers. I can put in some numbers at the top here. And it will spit me out some numbers across there. And the game here is I want you to tell me, what does the machine do to the numbers? Okay. Now, Yaz, if you can help me out with the first one here, I'd like you, please, to give me a number.
7.
7. So I'm going to put the number 7 into this machine, and the machine's going to gobble it up, do its thing, and it's going to spit out a number. And the number that it spits out is 13. Okay. So people are on the chat. Can I please get you? Maybe I might call people out one by one, actually. I might ask you to give me a number, and then I'm going to put that number through the machine. And the game here is that I want you to tell me, what is the machine doing to the numbers? Okay. So Aurelia, can you please give me a number? And I'll look at it on the chat. Number, any number. You there, Aurelia? All right, I'll ask someone else. 27. All right, here we go. When you put 27 into the machine, this is what happens. It goes, and out comes 53. Okay, another person. Let me see who's on here. Dylan, can you give me a number, please? Let me use a different color. Dylan, you on here? Can you give me a number, please? 32. You guys like big numbers. Makes it hard. All right, 32. Goes into the machine. and what comes out is 63. Okay. Anyone have any idea about what the machine is doing to my numbers yet? All right, I'm going to do one more. Mateen, can you give me a number, please? Pick a number, any number. It's weird that they're all ending up in 3. 18. All right, you ready? 18. Put it in. It is. There we go. So someone's got it. Someone said, what is the machine doing? It's doubling the number, then minusing 1. So let's have a look. Let's do 18 first. Double 18. You double it, it gives you 36. Take 1. And then do 36, take 1, and that'll give you 35. Okay, so it works for that one. And what was it say? Let's do it 7. So 7 times 2 is 14, take 1 is 13, right? So I'm going to say bang on, you got it right. Double the number, then minus 1 is it. Now, I'm just going to clear all this. Can someone tell me, now that we know what the machine's doing, can someone tell me what would happen, what would come out of the machine if I put an A in there? If I put an A into the machine, what would come out of it? Does anyone know? Can the machine even handle an A? That's another question. Yeah, the machine can definitely handle. What would happen to it though? What would be spun out? Interesting. So remember that the rule here is that you have to double it and then minus 1. So remember, let's go back to when I did the 7, right? If you double the 7 and then you minus 1 to that, you can do that to any of the numbers that we chose. Someone else chose 18, right? So 18, double it, and then minus 1. So notice that there's a pattern here that happens to every single number that we put in here. Someone else said another one. What was the other one? 32 was one, right? 32, double it, then minus 1. Right, so we can actually feed random letters or random symbols into the machine, and it will spit out something, but we just need to write it in terms of whatever we're putting in, right? Let me redo that, right? A, double it, so times it by 2, and then minus 1. So that very bottom one is what happens to my A when I chuck it into my machine. Now, in maths or in algebra anyway, when we've got like a letter multiplied by something, we usually write it like this, right? Just to shorthand it so that we don't have to keep writing the times. And that's just the convention we have. But we can put in random letters into the machine. We could actually put anything into the machine, right? We could put in smiley face, right? Smiley face goes into the machine, and what comes out, I hope that's not an actual human, but would be very deformed. You take the smiley face, you times it by 2, and then you'd subtract 1, right? And so does it have an actual number answer? Well, the answer is no, because we don't know what smiley face is. If we knew what smiley face was, then we could turn it into a single number, but we don't know what it is. So until we know, let's say we said smiley face is 10. Once we know it's 10, then the machine can spit out an actual number. 10 times 2 is 20, take 1 is 19. So that's this machine. I've got a different machine. It looks exactly the same, but it's got a different pattern. Okay, so I'm going to ask people again to tell me some numbers, and we're going to put numbers into this machine, and going to see what comes out of it. And then I want you to tell me again, what is the pattern that this machine is doing. So who haven't we heard from yet? Can we please have a number from, is it, forgive me, I'm going to butcher this name. Is that Senedy? What's a number that we can put into this machine, this new machine? I know it looks exactly the same, but it's a different machine. So, okay, okay, 22, I'm going to go with Senedy's first. So 22 goes into the machine. I'm going to have to change my pattern because it is that number's way too big for it. So let me just think of another one. Okay, I've got one. The numbers are too big for my other pattern. Okay, ready? So if you put in 22, what comes out of it is 16. All right, R of, you've put in, you want to put in 15. All right, let me get a different color here. So putting in 15, and you end up with 12 and a half. Okay. Can I please have another number? Aurelia, we're back to the start now. Everyone's kind of given a number, so we'll go back to the start. What's another number? 13. All right. You can choose any number now, by the way. I adapted this to be able to use for big numbers. All right, let me have a look. If you put in 13, you get 11 and a half. Okay, so anyone got an idea about what this machine is doing yet? Dylan, can you give us a number, please? 21. You guys like sticking around this area. Okay, ready? 21 is 16 and a half. Yaz, can you give us a number, please? One more, just for fun, or just for
32.
32. All right. If you put in 32, you get 21. I'm gonna put 1. All right. If you put in 120, you get 65. Minus 1.5 is not it, right? It works for 13. 13 take 1.5 is 11.5. It's not 2.5 because 13 take 2.5 isn't 11.5. Anyone got a good guess here what the pattern might be? I may have made mistakes. I hope I didn't. You'll have to fact check me here. Yaz, do you have any idea what the pattern might be?
I do not.
Okay, you ready? This is the pattern. You take a number. I'm trying to find the number. Okay, let's say you take 15. You halve it, and then you add 5. All right. So half 15 is 7.5. 7.5 and 5 is 12.5. So this is a pretty tricky one. You can do another one. 22 half 22 is 11. Add 5 is 16. So yeah, that was the rule, right? So we're halving and adding 5 in this one. Someone tell me, what would it look like if we put in an X? What would come out of this machine? Think back to what the rule actually is. Think back about how do you apply that rule to some letter X, right? So remember, the rule was we're halving it and then we're adding 5. All right, so how do we halve something? Well, remember, when we're halving something, we divide it by 2. So whatever this X is, we've got to divide it by 2. And then whatever that is, we've got to add 5 to it, right? So this is one way to write what happens to this letter once it goes into this machine. Another way to write it is this, right? Because in algebra, we generally don't write divisions as division signs. We generally write them as a fraction or over the number. Arav, you've got a question. You put your hand up. What's up? Type it into the chat. So look, that's another way to write this rule. Now, the one thing that I want to show you here is that in algebra, there's a reason why we use these letters, right? The letters themselves don't actually matter what they are. It's the fact that we're using symbols to represent an unknown number, okay? So what happens here is what this X can represent is any number. If I put any number into the machine, this is the result that's going to happen. So what I can do now is this little expression tells us what will happen if we put any number in. And so now if I got a 12, I could put the 12 straight into where the X is, right? So I can say 12 divided by 2 plus 5, and I can figure out what that answer is, right? Now, what I've just done there by putting the 12 in is something we called substitution, okay? We're changing what we don't know, right? An unknown quantity for a number, and that's called substitution. And so we're gonna have a look at today this idea of using unknown variables to represent situations. Now, where does this get used? Now, I know people say this all the time, but math gets used everywhere. People just don't realize it. How often might you use algebra? Depends on your job. Depends on what you do in life. Depends if you think this way. Maths is one of those things, it's kind of like a language where once you learn it, you know how to speak it, then you can apply it to things. But for those people who don't know math, who don't understand the symbols, and people who don't understand the ideas and the problem solving ability it gives you, they'll most probably either only use it at a very basic level or they'll never use it at all. So maths is like a language or a tool where you can go through life and not use it at all. But if you can use it, it makes life so much easier and it allows you to understand the world that much more. So let's have a look at some places that algebra gets used. This, can anyone take a guess? This is an equation. V equals the square root of GM divided by R. Now, I'm not expecting you to know what it is, so I'm asking you to guess. Guess what this equation does. Guess what it represents, right? Maths represents real life. It basically, we can use algebra to model things that we see. Sometimes they're physical things in the universe. Sometimes they're theoretical. Sometimes they're just ideas that were there used to represent. But this equation actually represents how fast things orbit each other. Right, so here we're talking about how fast the planets orbit the sun, but we could think about this in terms of how satellites orbit the Earth. So that equation back here looks very tiny, but its actual applications, or its actual what it actually is used to represent, is very, very large. Right, it helps us track where things are in the sky, how fast things are moving in the solar system and in the universe. What about this one? I don't know. Has anyone ever heard of Ohm? Ohm's Law. V is voltage. I is, what's I again? Current. R is resistance. Let's forget the other two down the bottom for a second here. Ohm's Law. Anyone know what this relates to? Tell me the field it relates to. An ohm is a measurement. Well, I mean, an ohm was a dude who made up these rules, but it's also a very common measurement in electronics, right? So your computer or whatever you're viewing this webinar off is using Ohm's Law. And if you're ever interested in circuitry and electronics, it's one of the most basic fundamental rules that you'll learn. right? Now, last couple, Boyle's Law. Anyone know what Boyle's Law is? If you know what this is, I'd be very amazed, because I don't think you learn this till like year 11 chemistry or something like that. Boyle's Law, P1 times V1 equals P2 times V2. This has to do with pressure and sprays, right? Basically, it's talking about how the pressure and the volume are related in two things. So whenever you spray yourself with deodorant, you're using Boyle's Law, right? The amount of liquid and the amount of air pressure in there, when you press the button, releases the air pressure, and you get sprayed with deodorant. Spray guns, when you see people spray painting their homes or spray painting cars. Anyone know what this one in the bottom right is? Anyone know what that picture is of? That's actually of a pressure cutter or a water jet cutter. And essentially what that is it shoots water at such a high speed that it cuts metal, right? And so this little thing is just jetting water straight down and making patterns or cutting lines into this piece of metal. Amazing, right? So yeah, all of these things, right? All of these equations, you look at them, you go, what are these random letters? Now, to us who don't know what the equations are, those letters, we'd need to go figure out what those letters are, right? What they represent. Each of those represents something, some quantity that can change. So what this is really saying is that if I'm, let me go back to one that's simpler. Let's go back to this one here, right? Let's say P times V equals a constant, right? So what this is saying is that if I know the pressure, I can figure out the volume if I know this other constant, right? So like these are all variables which can change, except for constant. Constant means it stays the same. But if I know parts of this, it means I can figure out the other sections. So here, these letters are representations of an amount, and we don't know what those amounts are, right? So the question that I get asked the most is, why in algebra do we need to use letters? And the reason is because a lot of the time we don't know things, and when we don't know things, we represent them as a letter, and that allows us to work with them even though we don't know it. So here are some other applications of algebra. Lots of random equations. On the top left, we've got basically algebra in economics. When you buy and sell things, when you're doing business, you're going to be using algebra to try and figure out how to best do business. On the bottom left, we've got finance. So if you're taking out a loan, if you're doing some savings, if you're trying to figure out how to make money, happens in finance too. This is in engineering. In the top right, that's modeling infectious diseases. We can use algebra and maths to do that. And then on the bottom right, we've got in art. And very rarely do people connect art and maths together, but there are actually some very interesting connections between what we deem as beautiful and things that look good, and maths and ratios and proportions and that kind of thing. So maths is really embedded everywhere. It's just that a lot of people don't recognize it, and a lot of people don't ever use it. So let's actually get into the teaching side of things. The other day, I needed to build I'm going to build a raised garden bed, and I had nowhere. What's the word? I didn't know where to start. Some people have raised their hands. If you're raising your hand, just put a question in the chat. And so I was building a raised garden bed, and I wanted to know, right, how much wood I would need to build a raised garden bed. So just in case you don't know, right, I'm just going to draw one on the screen, right? A raised garden bed is like a box that you build, and in that box you fill it up with soil, right? So you fill it up with soil, and then little plants grow out of it. Now, the whole point of raised garden bed is that you can kind of control the soil that's in the bed, and it just makes things easier to grow and plant because it's not at ground level. You don't have to like bend down all the time, and you can either kneel or stand and do your gardening that way. So anyway, raised garden beds. If your family doesn't have one, I suggest you start looking into gardening. Super fun. Love eating what I grow. But anyway, I digress. So building a raised garden bed. And the one thing that I had to try and figure out was how much wood would I need to build this garden bed? Now, I'm going to reduce that down to a simpler problem to what is the perimeter? Oops, I'm on an eraser. Hang on a second. My voice is dying. Give me a second. What is the perimeter? I keep going on a razor. I don't want a razor. What is the perimeter of the garden bed that I'm going to build? Okay, so I measured it out, and I think I measured it out. So I want something that's about 1.2 meters across, and it's probably what was it? It was probably like maybe 0.8. No, it was like 0.6, I think, 0.6 of a meter in its length, right? So width was 1.2, 0.6 was the length. And can someone tell me, how do you calculate the perimeter of this garden bed that I was planning to build? Anyone? Just in case, I guess I should say we haven't covered this previously, but perimeter means what's the length around the outside of this shape. So the length of the outside of this shape is adding up all the sides. So I've got to add up this side. Oh, I just erased it. I've got to add up. Oh, that's not what I want. I've got to add up this side and this side as well. I've got to add up this side here and this side here. All right. So when I add them up, 0.6 and 0.6 is 1.2. Someone's got it. What have you got? Yep. Close. You said 0.12, but it should be 1.2 meters, right? So 0.6, 0.7, 0.8, 0.9, 1, 1.1, 1.2. All right, so it's 1.2. And then the other side is 1.2 plus 1.2, which is 2.4. So that means my total perimeter is, P stands for perimeter, right? A letter that represents something variable. That's what I'm using right now. So P equals 1.2 plus 2.4. And that altogether gives 3.6. Okay, so that's one way of doing this. There's a quicker way. Does anyone know what the quick way is? All right. Rather than having to add up separately, what could I have done to make this simpler? So I didn't have to write out like 3 or 4 lines of working. What could I have done? Let me erase this. Right. I could have done this. I could have said, okay, my perimeter, and you probably will have seen this. Someone's got an answer here. Yeah, just times them by 2, right? So I could have done this. I could have said 1.2 plus 0.6, all of that multiplied by 2, right? And that would give me my perimeter. 1.2 plus 0.6 is 1.8, and 1.8 times 2 is 3.6. Right. So notice that I can make it simpler. I can make it have less working, and that's really what maths is trying to do. It's trying to simplify everything as best as possible. That plus I'm really lazy. So yeah. So we can kind of do what we just did before in several lines and just break it down into like a single line, and then just calculate what that single line is, right? So now the question here I want to ask is, well, what happens if I didn't know what the side length was, one of the side lengths was? So let's say I didn't know what the length of that particular length was going to be. Can someone please give me a letter to represent the side that I just rubbed out? Pick a letter, any letter, it doesn't really matter what it is. First one in the chat. A, sure. I'm going to use A. So that side length is A. I'm going to change that to, what do you call it? I'm going to change that color. And what that means is that now that I don't know one side, I can't actually calculate a single number anymore. I don't know what the total of that perimeter is going to be without knowing what A is. And that does make things hard, but at the same time, what that does mean is that I can actually rewrite this to determine the perimeter of this rectangle regardless of what that side is. It can be that now that we've represented that side with A can be anything. It doesn't matter what A is. So I can rewrite this as 1.2. I can rewrite this as 1.2. Whoa. Let's try again. 1.2 plus whatever my other side length is. I don't know what it is. It can be anything. And whatever that sum comes to, I multiply that by 2. Right? And so notice that this now tells me if I have a width of 1.2 meters and a length of anything, this is what my perimeter is going to be. Can I calculate what that perimeter is going to be as an actual number? Like I said before, no, not until I know what A is. But if I don't know what A is, this is the best, I guess, answer that I'm going to get. Now, I can take it a step further, right? I can go, well, let's say I didn't know what the width of my planter box is going to be. So let's say I'm going to erase this one here. I don't know it's 1.2 meters anymore. And I'm going to replace this with another letter. Someone else said B, so I'm just going to take B. Right? Oh, B. Hang on, I'm going to undo that one because I've used yellow on the other side. So I'm just going to pick a different one. Here we go. B. And now I don't know any of the lengths of my rectangle, but guess what? I can still calculate its perimeter based on that the width is B and the length is A, right? Can someone tell me, how is my equation going to change at the top? If I don't know that my width is B anymore, I didn't know that my width is 1.2, how's it going to change my equation? Right. Now, obviously, this 1.2 on the left here can't be there anymore because we don't know that the width is 1.2. So I'm just going to put B in here. And now this equation of B plus A and all of that times 2, and a lot, by the way, everyone's been writing stuff into the chat and all of those things are also correct. Now I can find the perimeter of my planter box for any width and any length, right? And this is helpful to me to calculate if let's say all of a sudden I wanted to make a planter box that had a width of 0.8 meters and a width and a length of 3 meters, I can do that using this equation. I don't have to go through that whole process anymore of going, okay, what are all the sides, and do it step by step. I can just plug the numbers that I want into this equation and calculate myself an answer. And that's the whole point of an equation. It's to be able to generalize for any circumstance, and then I can use it quickly as a tool whenever I know the lengths of my rectangle. So someone else put up their hand. Any particular reason why you're putting up your hand, sir? Type it into the chat. Now, again, putting up your hand isn't helpful unless I know what you want to say. So please just type it in the chat. So so now my equation for perimeter of this is B plus A all times 2. I'm going to take it one step further because what we don't like to do in algebra is we don't like to write time signs. So I'm going to put it like this, 2 times B. I'm just going to change my color here. B plus A, right? And some people have written 2A plus 2B. That's perfectly right. Someone's written B2 plus A2. to. You are kind of right, but what we don't ever do in algebra is write the number second. So we always write the number first. So have a look at Senadi's answer. That's the way that you want to write it. So that's the whole point of algebra, which is being able to generalize, being able to work with numbers which are unknown or quantities which are unknown. That's the whole point of algebra. Okay. Could we get a full number as the answer? The answer is yes, if we know what the side lengths are. So if we know that A is a number and B is a number, once we know what those numbers are, we can calculate this. So let me show you an answer. Let's say, let's say I wanted to make a planter box that was 5 meters long, 5 meters wide. And then I also wanted to make sure that the length was actually 3 meters long, right? It's going to be a huge planter box. As soon as I know that B is 5 and A is 3, I can calculate and get an answer. If I don't know what A and B are, we're going to be stuck with the equation just being in terms of A and B. So let me show you. Now, what I'm about to show you is important because what I'm about to show you is the skill of substitution. Okay, and this is how we substitute. I take the equation that we have, and everything that is not a letter, I am going to do the same. I'm just going to keep it exactly the same. So the 2 at the front is not a letter. It doesn't change. It's not a variable. So I'm going to rewrite that as a 2. Then I'm going to write my bracket because that's exactly the same. It can't change. And I'm also going to write the plus sign the same because that doesn't change. And I'm going to write the other bracket sign the same. The only thing that changes is the letters themselves, because the letters change. We're substituting the letters for numbers. If you think about if you're playing a game of basketball and you ask for a sub, what does that mean? It means that you want to change position with someone on the bench so they can come in and play for you, right? So remember, substitute means to change, to replace. And so where I see B, I can replace that B with a number because I know what B represents now. B represents the number 5. So B becomes 5 meters. So I'm going to change B for a 5. And A doesn't represent A anymore because we know what A is. We've said we want to make a planter box that's 3 meters long. So A here can be changed into 3. Now notice that when I substitute, the second, this one here and this one here look exactly the same, except the letters are changed for numbers, right? And once you've done that, that's what we call substitution. Now, once I've substituted all the letters for numbers, that's when I can find an answer. So I can now say, I'm going to do it over here because I'm running out of room. 5 plus 3 is 8. And 2 times 8 is 16. So that means that I'm going to need 16 meters of perimeter for my planter box. Okay. So someone else asked about area. If we wanted to do area, we'd have to completely redo the equation because the equation for perimeter and area are completely different. Okay, so I'm just going to check how much time we have because I wonder if we have time. All right, we've got a little bit of time. So let me erase everything. So let's quickly do this for perimeter. I mean, it's for area. Okay. So let's go back to what we said before. Let's say I've got a width of 5 and a length of 3 again. Now remember, area is different to perimeter. Perimeter is the length around the outside. Area is how much is on the inside, this green stuff. What is the area inside this rectangle? And remember, the way to do that is to basically multiply the sides of a rectangle. I don't have time to go into geometry. Otherwise, I'd talk to you about how we do it and how we get there, but essentially, and why we're just multiplying 5 by 3. But essentially, the area is equal to, in this case, 5 times 3. 5 times 3. And if we were to calculate that out, 5 3s are 15 square meters. Okay. Now, because in the previous one we added things together and doubled, notice that we don't do that in area. In this one here, all we do is we multiply the side lengths. And you would have seen this equation, right? You would have seen, instead of 5 and 3, you would have seen this says width. Oops. Width. And the other side is length. That's an L, it's a curvy L, right? And so you would have seen this equation. Area equals length times width. And that's where that equation comes from, right? Instead of knowing the length and the width, we just replace them with numbers because they're unknown. And then we just multiply them together to figure out the area of any rectangle. So let's do some Mathspace. You ready? We're going to do 5 minutes and then we're going to go into our game. All right, so let's move this over a bit. Okay, I'm just going to log in. I might actually do it like this. Can you see my new screen? Someone tell me, please. I've gone incognito. Can anyone see my incognito screen?
No, I can just see the Mathspace website.
All right, let me reshare. Okay, that was what I was trying to do before, yeah. I couldn't get it to work. All right, anyway. All right, so we're in here. Now I'm just gonna go to the textbook. Out of curiosity, for those of you who are with us today, can you type in the chat, do you actually have Mathspace? Type into the chat for me, do you have Mathspace to use? Okay, no, no, no. Oh, interesting. So a couple of people said yes. Two people said yes. 3 or 4 people said no. Okay. Now, on the left here, I'm going to find my my topic, which is patterns in algebra, and we're doing introduction to variables. We're going to do a couple of these, and then we're going to do a couple of substitution ones, right? I'm going to show you through them. Now, here we go. Now, when you're in Mathspace and you're looking through the questions, you can click Start Adaptive Tasks to just start from the start and go through, but I'm going to look at each of the individual questions and pick out which ones I want to do. I'm going to start with the first one. So if I want to do it, I just click the 3 dots, click Try Question, and then we're going to try this question. So let's have a look. Now remember, in algebra, we have these letters, which are called, there's 2 words for them, that can be called variables, but their technical fancy name for them is called a pronumeral. So variable just means a letter a symbol that can change number. Pronumeral, I think it means 4. Pro means 4, numeral means number. So you're saying this letter is 4 a number, represents a number. I totally just made that up, so please fact check me, because it just dawned on me that's probably what it means, but go look it up. All right, so the key shows how many apples are in each size box. And so the blue box represents there are X apples, and the green box represents there are Y apples. So if Bart has X apples, which box does he have? A or B, please. Tell me which one it is. Right? It's the blue box. It's the A box, right? Because blue represents X, right? So, and he has X apples. All right, sweet. That was easy. You know what? We actually no. Okay, so that was easy. Let's try another one. Let's try a harder one. Here we go. Oh, this looks harder. Tom is selling some apples in boxes and some apples individually. Apple represents 1 apple. Oops. The apple represents 1 apple. The green box represents Y apples, and the blue box represents X apples. Okay, so remember the representation here. Oh, hang on, I'm going to try the question. Here we go. Let's try this one. Okay. How many apples does each symbol represent? Box is equal to how many apples? Green box is how many apples? Someone tell me. Y apples, thank you. Just read the legend, right? Green box is Y apples. Apple symbol is represented to how many apples? 1, got it. Let's submit this. All right, so using the values from part A, how many apples does this image represent? Oh, this is a bit trickier. Anyone have a guess about what this represents? Now remember, oh yeah, Senator, you crushed it. Remember that we can multiply, add, and subtract to the variables or the pronumerals. So I've got 1, 2, 3, 4 green boxes, and each green box represents a Y. So I have 4 of these Ys. I'm going to write 4Y, and 4Y, remember, means 4 times Y. And then I've got 1 normal apple, and I know that literally represents a single apple, so I can write just +1. Boom, got it. All right, let's try another one. Let's go to the hardest one. Here we go. Oh, this looks hard. All right, let's try this question. Okay. Now, if you do have Mathspace, I strongly suggest you come into here and you practice this yourself and master as much as you possibly can. So ready? Using the key below, which of the following options represents 2A plus 2? The blue box represents A oranges. The green box represents B oranges. And the orange represents just 1 orange. So which of these, A, B, C, or D, represents 2A plus 2? So remember, A is the blue box. Great, so you need 2 blue boxes, and you need 2 oranges by themselves, which is 2 oranges, that's 2 green and 2 oranges. Someone tell me, what is A? If you had to write out A, what would that be? If you had to write out 2 green boxes and 2 oranges, what would that be represented as? Yeah, Aurelia, you got it. You're just missing a symbol in there. It'd be 2B plus 2, right? And this would just be 2B. This would be 2A. And this one here is your 2A plus 2. Too easy. Okay, let's do, okay, so what I really want to do was actually move into substitution. Now, in terms of the working that I'm showing you, please be mindful that you should be doing your working out in pretty much exactly the same way. And the reason for that is because the way that we represent algebra, like the way that we write it and communicate to other people, is super important. There are a whole number of rules that are based around that. And it's a way that everyone knows how to write and understand algebra. So it allows you to just people to read and communicate clearly if they're all following the same rules. All right, so this one here, it says, find the value of u divided by 6 when u equals 42. So again, remember, u represents a number, an unknown number. Don't know what that number is, but then in the next part of the information, it actually tells you, well, we know what u is actually 42. So we're gonna use that information to write out an equation. So I've got u divided by 6, and I'm gonna substitute. And remember that when you substitute, can someone tell me, what does substitute mean again? I know the answer is 7, but remember, what's important here isn't the answer. What's important here is the process of substitution. What's important here is being able to write this out, okay? So someone tell me, what does substitution mean? The letter is an unknown number. The pronumeral or the variable is an unknown number, but what do I do when I substitute? What's the process? Right? So remember, think back to what substitute might mean in sport. Think about what would you do if you were cooking a recipe and the recipe said you needed to use butter, but you had no butter. and you had to substitute butter for something else. What does that mean? Right? So remember, substitute means to change, to replace, to swap. So when I'm substituting here, I want to swap the U, instead of the unknown U letter that I don't know, I want to replace it with what I do know. And what I do know is that U is actually equal to a number, and it's actually equal to 42. So I change U for 42, but remember, I keep everything else in my equation the same. And so now I've got the equation 42 divided by 6. And now this is when I calculate my answer and figure out what the number is. And so I say, well, 42 divided by 6 is 7, right? Now, again, what's important here isn't the answer. What's important here is what I've just shown you, which is how do I write out this this algebra? How do I write out this substitution? And if the only thing that you get from what I'm showing you is how to display your working, I'd be a very happy teacher. So let's have a look. Now, what I'm going to write in here isn't the answer, okay? Because what Mathspace wants is it wants you to show your working as well. So I want to write in here, I'm going to substitute, I'm going to replace the U with 42. And notice that Mathspace says, yeah, you're on the right track. And then I'm going to write my other line of my final answer in here. And then I've got this one correct, right? So when you're writing in Mathspace, please write in as much working as possible. Do you have to write in the working? Technically, no, you can write in the answer. It'll just tell you, yes, you're right. But as a teacher, as a student who's looking to get better at maths, please do the working. All right. Let me get rid of this one. Let me do, how much time do we have? We got 5 minutes. All right. Let me do one more question, and then we're going to go to Gimkit and play a quick game. All right, you ready? So this is find the value of x and y if x is 10 and y is 14. So what this is asking you to do is replace x and y for the numbers that we know. Now, I know you all know the answer straight away because it's pretty easy to add 10 and 14 together. But again, what I want you to do is have a go at writing out the substitution. Have a go at doing the working. So x plus y equals. Now, in this case, I know what x and y are. I'm going to color code them. X is this one, and y is this one, right? So if you ever get stuck, feel free to help yourself by putting it in colors. And so I know that x is 10, so I'm going to change x for 10. I'm going to substitute. Instead of writing x plus y, I'm going to write 10. And remember, because the plus is not a variable, because it's just the same, I'm going to keep the plus sign the same. And then I'm going to change y for the number that I know, which is 14. Okay. And then this is now when I now calculate. I just go, okay, because I've substituted everything, I know what they are. I just go 10 plus 14 is 24. And that's my answer. Now, a lot of you are saying to me, I know, well, a lot of the things that students say to me is why on earth do I need to write this out when I can do this in my head much, much more quickly? And the answer to that is well, the problems that we're doing right now are really simple. They are things that you can do in your head. But there will come a point when you have equations that are so complex that it's impossible to do in your head. No matter how smart you are, there will be a point where you can't just compute everything. So writing this out is important because once we get to the more complex math, this enables you to do those calculations without getting all jumbled up, and making it easier for you to do them. So please practice the substitution, the writing out, and the working out, okay? Because that's really, really important, right? And so notice that I wrote each line into Mathspace, and we got it right, okay? Any questions about substitution or variables or algebra in general? Right? No questions? All right, I'm gonna jump into Gimkit then. Oops, I'm on my clear thing. Get out of this. All right. So we got just under 5 minutes left. So, we got 3 minutes left. Let's do a quick one. Now, I did not create a new GIM kit today, so we're going to play an old one. Let's see what you guys remember. So if you while you're waiting for me to kind of load up the game, grab a different device or what's it called? Grab a different device or split your screen. We're going to do percentages today. I don't know if you guys are playing. I'm going to do team mode today, especially because it's the last time that I get to actually practice this. Yeah, so you playing?
Yes, I'll play. I'm just going to get my calculator.
Oh yeah, you need a calculator for this one. I forgot that. All right, we're gonna do a time limit on this one. We're gonna do it for 5 minutes. This is gonna be really, really quick. And so you're gonna need to answer furiously. Okay, how are we going here? All right, let's start it. Let's go. All right, 5 minutes. Jump into the game. I really wanted to play that game mode where it was like a big boss mode, and it was like one person versus everyone else. Oh, but unfortunately, it's not there. It's not available. Okay. So 82097. All right. Is there only 5 of us today? Who else is in here? 2, 4, 5, 6, 7. There's 7 of us in the call. We need 3 more players. We need at least 8 people. Whoa! We need to reset this. Hang on. Let's try again. Sorry, we're gonna have to go back in. Oops, I selected the wrong one. Oh, it doesn't matter. Team mode. Plays per team. Here we go. 2 players per team. You can't have. Oh, here we go. Why was that working? All right, 5 minutes. Let's start again. Sorry, everyone. Log back in. Okay. Reconnect, please. Okay, are the other 2 people playing? Who don't we have here? I don't think we have. I can't tell if Mateen is here or Dylan or Arav. You guys coming in? All right, we're going to start, and if you want to join, you join. Okay, Mateen's in here. All right, we're going to start. If you want to join halfway, you join halfway, right? All right, let's see how this works. I don't know why it says go find the rest of your team. How does this work? Oh, me and Cindy, let's go, Cindy. Let's crush it. Let's go. If you want the what do you call it? Game codes at the top. If you want to join. Oh no. Oh, I need a calculator. Remember the percentage signs. I forgot about this. Round to the nearest whole number. decimal for 2/5. Sure, I can buy something. 1,500. 2K. Whoa. I forgot you can do this. You guys waste your money. What is the decimal for 4/5? Maybe it's not such a waste. I can't see what I'm doing. What fraction is equivalent to 0.875? Okay. 10K for more money. Jeez. Street. Yeah. How are we going? Oh, they're winning, Cinity. Let's go. Let's go. Let's go. What fraction is going to? Oh God, I'm gonna guess. Can't see. What is it over half? I'm gonna guess. What's a? What's it called? 7/8. 500 37 blue. The rest were red. What percentage of the lines are red? Oh God. Oh, blur is so good. It's so hard. 3/8. Oh, we are crushing Cinity. Oh, we got Dylan as well. Boom. Backup has arrived. Oh. You guys are wasting your money trying to stop me. I'm a beast. I cannot be stopped. 1 minute left. The subtract is actually a pretty good option. What fraction is good? 0.2. 45%. Oh no, I got it wrong. Boys, 63. Oh geez, 105 out of 1,000. 21 out of divided by 5. There's a decimal. 5/8. Buy something. 15,000. Jeez. 12,000. 10,000. All right, I need 10,000. 3 seconds left. This game over. 7 out of 20 is. Yay! We win.
Oh no!
Good job, everyone. Thanks for playing. Okay, so I'm just going to stop sharing there. And all right, well, this brings us to the end. We've gone 7 minutes over time, but thank you so much, everyone, for coming and supporting Mathspace and supporting Year 7, this Year 7, what do you call it, Mathspace Academy. I wish all of you the best, and I hope that you and all your families continue to remain safe. I probably won't see you for a very long while, but if you remember back there was an email address that I put out there previously. So if you want to get in contact with me, want to ask any maths questions, feel free to do so, and I'll try and help you out as best as I possibly can. So no, really, really appreciative of all the people who've been coming. I know that most of you, all of you guys have been coming for the last, 4 or 5 weeks. So thank you so much. Thank you again to Yasmin. You've been an amazing help for me, and I couldn't have run this without you. And so if you want to say any last words, feel free
I
to type them into
do.
the chat. Oh yeah, go Yasmin.
Thank you to everyone who came. This is really fun, and I hope that they got something out of it as well. So yeah, hope everyone stays safe.
Absolutely. Okay. Have a good one, everyone. Take care. And who knows, maybe we'll meet again in the future by a twist of fate. See you later. Bye-bye.